and you use these prefixes. Where you are literally saying how many atoms of each element that you've got. The covalent part's the easier part. Because if we look at SCl2, S is sulfur, Cl is chlorine, correct? That's just the names of your elements. We alter this to be the IDE, so we're dealing with sulfur chloride. That gives it a compound ending, not just an element ending, and that indicates that these are attached together. And then you come over and look at your subscripts. Well, I guess this is implied to be a 1. No subscript in the formula means no prefix on the name. But that 2 is di. So sulfur dichloride. Literally 2 chlorines. Sulfur with 2 chlorines. What's P2O5? What's P? Phosphorus. And oxygen becomes oxide, right? But now because we have subscripts, we've got to think about prefixes. What's this going to be called? Okay. Diphosphorus pentoxide. For 2 and 5 respectively. 2 and 5. Question about that? The covalent ones are very straightforward. The problem comes when people try to look at this and call this calcium dichloride. That's wrong. Because these prefixes are for covalent things, and that's ionic. So that would be applying the wrong system. Now that's the only 2 I've got up here that are covalent. But do you see how that part works? As long as you know these prefixes, you're just inserting it to say literally how many atoms you've got. Ionic. The thing about naming an ionic compound is you're really not naming the compound. You're naming the cation and the anion as if they were completely independent of each other. Monatomic means single atom. Polyatomic means several atoms. So monatomic cations would be things like Na plus, Fe3 plus. It's single atoms with a charge. And the monatomic cations you name the same as the elements that you make them from. So if Na is sodium, if this is the sodium atom, then this is the sodium ion. And you know it's a +1 charge because it's in group 1 of the periodic table. That's all it ever can be. Group 1 is always +1, so you just call this sodium. Group 2A is always +2, emphasis on always. So that's just called the calcium ion. But what you got to be careful of is there's some elements that form more than one possible charge. And you can't call both of those iron, right? Because that would be ambiguous. Well, you do call them both iron, but you have to qualify that a little bit with a Roman So the naming system for monatomic cations is you give the name of the element and the charge is a Roman numeral, unless it's considered redundant. There's no point in saying a sodium that has a +1 charge, because there is no other kind of sodium. It's always a +1 charge. But if you're talking about iron, then charge is not constant. And you've got to specify whether you're talking about iron 2 or iron 3, because this would be iron 2 chloride, and that would be iron 3 chloride, and that's a very different compound. Polyatomic cations we can cover really quick because there's really only one. Polyatomic cation, and we've already defined it, that's ammonium. And ammonium is always a +1, so you don't have to call it ammonium 1. You just call it ammonium. And a handy thing for that, to help you remember that, is whatever periodic table you're using for reference, just go ahead and mark ammonium in as an honorary part of group 1. That way you'll know that it behaves like group 1 and forms a +1 charge, and it doesn't use a Roman numeral in names like the elements in that column. And that way, whenever you look at the periodic table and you see who's in that column, you're reminded that ammonium behaves like them. Just scribble that in. All right. Questions? Everyone signed the roll sheet, correct? All right. Well done. There will be some naming on exam 2, so work on this.
Okay.